This video demonstrates reusing and converting legacy DXF or DWG information within SolidWorks. In SolidWorks, I'll go to File Open and change the file of type to either DXF or DWG. Then, I'll browse to the file that I'd like to convert and double-click on it. This will open the DXF DWG import wizard where I can choose how to work with this file. First, I'll use the DWG editor. 3 seats of this come with each seat of SolidWorks. In this program, I can work with the 2D file in an AutoCAD style interface. This is to maintain your legacy data without altering the original file type. This allows SolidWorks users to maintain files complete with line styles, layers, and fonts without having AutoCAD. I can also convert the file into a SolidWorks drawing. If the title block is on a layer, I can transfer it to a sheet format within SolidWorks. I can also manipulate paper size, scale, or geometry positioning on the next page of the wizard. Here's the drawing converted into SolidWorks. I can view only the title block and easily save this out as a template in SolidWorks so I can reuse my existing AutoCAD geometry in SolidWorks. These templates can also store information such as drawing standards, units, and detailing information like arrowheads. So once set, you will always have the same settings within your template. Just double-click on the template you want and your drawing is ready to go. I'm going to bring in another DWG in as a drawing. The wizard can also act as a viewer with its preview window to look at the drawings before conversion. If I convert this to a SolidWorks drawing, I can also add parametric intelligence to this 2D information. I'll bring this drawing in with all the dimensions from AutoCAD, and I can reuse these later. I want to create a model from this drawing. Notice that I have the same layers that were set up in AutoCAD. I can turn off the layers that I don't need. I'll zoom into this view to see a bit better. Notice if I try to change any of these dimensions, they are currently just static annotations. Also, the imported geometry is seen as lines, arcs, splines, or whatever, but they are not locked down or have rules like horizontal or perpendicular. I'll press the undo to go back to the original geometry. Now, I want to box select the view and from the Tools pull-down, choose to constrain all the relations. Now when I move the geometry, it will keep the orientation to the original import as compared to the surrounding geometry. I'm going to select the items again and go to the Tools pull-down to attach the original dimensional values to the geometry. This will make the dimensions driving parametric values. This means a dimensional change will rebuild the geometry automatically. Notice the line on the other side remains collinear due to the relations added to the geometry earlier. Now that I've got an intelligent 2D information, I'm going to copy this information to my clipboard and open a SolidWorks part. In the part, I'll select a default plane and paste this geometry into the part. You can also cut and paste information directly from AutoCAD if you have both programs on one machine. I'll right-click this line and select the midpoint. Then I'm going to attach the midpoint to the part origin. Now, using Instant 3D technology, I can select a line on the sketch and drag it out into the Z direction. If I hold down my M key, I can automatically get a mid-plane extrusion. The final way to convert this file is to import it into a new part. Again, I have full layer access and control, so I can omit any layers on import. When I press the Finish button, I'm placed into a SolidWorks part, and the imported geometry is placed on the front plane. I can select geometry and on the 2D to 3D toolbar, pick its orientation. I'll select this geometry and paste it to the top orientation. This geometry goes to the side orientation. I can also pick a line from one of these views and align it with a line on another view. Section views or details can be deleted with a right-click option from the Feature Manager tree. I'll pick a view and choose to extrude it. Because of overlapping geometry, I need to specify the contours of the sketch to extrude. I can also pick contours that I'd like to ignore. I'll use this point on the top view to determine the extrusion depth. Here's a basic solid. I can also use a cut to remove material based on the outside edge of this side view. Now I've got a solid model without having to sketch or dimension anything. And since this is a 3D volume, I can instantly get information such as weight, volume, and center of mass within SolidWorks.